Okay. I took estimation of student knowledge using student modeling. We can use. I'm using student modeling to estimate student knowledge retention. So coming to introduction, the main goal is to predict student behavior on the immediate next action. It was being investigated by the researchers for many years, but this paper investigates the predicting student performance after a delay of 5 to 10 days, or more, or like a week or more. So to determine whether and when the student will retain the material seen. Uh, like uh, Two aspects have been was very interesting in this. So the first one is that influencing retention are different than those influencing short-term performance. Especially, they found that number of student correct and incorrect responses were not readable. For the long-term performance, and this result in contrast to most of the student modeling efforts on predicting performance. So, and the second one is that answering the questions of whether a student will retain a skill is more useful for guiding decisions making in like ITS, which is intelligent tutoring system, than predicting the correctness of the next response. So, in this, they're going to introduce an architecture that identifies two approaches topics that are meaningful for intelligent tutoring system decision making. So here, the main is the field of educating data mining that has been focusing on predicting correctness of the next student response. So in this, they have two common approaches for student modeling. They are knowledge tracing and performance factors analysis. So both of these approaches focus on examining past student performances and predicting whether the student's next response will be correct or incorrect. So the source of both of the techniques is the student's pattern of correct and incorrect answers. So coming to knowledge training, knowledge training observes whether the student responds correctly or not, and it also uses its performance parameters such as guess and slip, so to update its estimation of the student's knowledge. And coming to performance factor analysis, it works simply and keep track of the number of correct and incorrect responses of the students that has made on his skill. And in addition to that, some versions of a performance factor analysis also make use of an item which is difficult parameter to account for an complexity. So, and PFA, it also takes the form of the logistic regression model. So predicts where the student uh, Okay, predicts where the student will respond to an item correctly and estimates if coefficients of the number of correct and incorrect responses that maximize predictive accuracy. So, like a connection with the student modeling is a mastering learning. So in mastering learning framework, the student continues to practice a skill like until he got mastered. So exactly what does it mean is that it depends upon that the mastery varies, but typically involves recent study performance. Like for example, knowledge training suggests that the probability of a student allows the skill exceeds 0.7. Like if it is exceed like 0.95, then it is called as mastery. It's called as mastery. So it is also evident that local measures of the student correctness are not that sufficient. So students do not always retain what they have learned. So this is all about the introduction. And coming to student retention analysis, um, like to find the student retention analysis, like it is not like to find it is student retention is predictable or not. The Wilde logistic regression model with using 27,468 data points, with the primary and the secondary schools with delayed practice opportunities. So the dependent variable is whether the student responded correctly on this delayed output, and the user identity and the user skill are factors in this model. So in the student retention analysis, they use following as a covariance, treating incorrect responses as 0 and the correct answers as 1. So incorrect is a number of prior student correct responses on the skill, and the n incorrect is a number of prior incorrect responses on the skill, that are both used in PFA models. So, and the end day seen is a number of distinct days on which student practice in the skill. This feature distinguishes the students who practice more days with fewer opportunities each day for those who practice fewer days. Coming to Gmean performance, the geometric mean of the students' previous performance, they use a decay of 0.7. Like for a student and a given skill, here we use opportunity that we count the student has on the skill. So on that skill, so we compute the geometric mean of the students using students' previous performance using this the formula. So when we compare to a geometric mean time, it's G mean time. So it is a geometric mean of the student's previous response time. That is, we calculate by using it's the same decay like 0.7, like same as a geometric mean performance. So for a given student with a given a given skill, the performance of the geometric mean of the student previous time is calculated by this formula, that is G mean time opportunity minus 1 into 0.7 plus response time opportunity into 0.3. That is a decay. 0.7 is a decay time. And coming to slope, the slope of the students, slope 3 is the slope of the students that are most recent 3 performances. Like they calculate 3 recent performances. The slope information helps to capture the influence of recent trends of the student performance. And coming to delay since last, this is the number of days since the student last saw the skill. So this feature was designed to account for a gradual forgetting of information by the student. And coming to the last problem difficulty, so it is a term that actually the problem easiness of in our model. So it is represented using the percent correct for this problem across all the students, where in this the higher the value is, the more likely the problem can be answered correctly. And coming to the parameter table of covariates in model 1. So these are table which shows the parameter of the covariates in model 1. The b value are the beta coefficient values, and p values for each covariance. So in this table, beta values means the larger the covariant is, and more likely the student respond to the problem correctly. And so for training purpose, they took to 26,000 of the data points. So for training assessment data, we got a retention of 0.25. Since the model is perfectly trained, but it is least strong to be it is least strong to be predictable. So to strengthen the results, they built a set to validate the model. So we use mean value of user parameters of the model. So as an approximation of the user parameter in the testing set, we also did the same thing in the skills that only appear in the testing set. So in this model, it was it was a little bit low. So it was comparatively a good fit with other attempts at using PFA. And coming to if by considering the overall performances by excluding these items. We are also estimating the students' proficiency in in different domains in less contaminated with forgetting and the spread estimate to students' knowledge. So they trained the same for the same data model of 26,000 as the same as the previous model. So the first one is a non-first p correct has been estimated beta coefficient of 3.83 with a p-value of 0. So the retention is 0.21 on this, which is reasonable and model fit. So this is caused by the substituting the person correct. So on non-first encounters for the user ID. And then they also, for the curiousness, they also further went for the general linear model with user ID and a random effect. So that's a residual as the dependent variable. So the retention was 0.235. So this was the student overall percent correct in contest where forgetting was minimal. So it vary systematically by user ID. So thus it appears that some constructed beyond performance such as forgetting that will be vary by the student. So coming to enhanced intelligent tutoring system, it's a learning cycle. Like it actually focus mostly to discover new problems on the EDM field that can be led to higher mastery learning rate in the intelligent tutoring system. So the following figure is which allows in intelligent tutoring system that aim for students long-term mastery learning. So in this, it mainly focus on the diamond which is on the left side. So that is whether the student has mastered a skill rather than using logic criteria to decide whether mastery has occurred. So in this, they train a model to decide mastery based on predicted performance. So beyond this EDM work, some review machine mechanism for intelligent tutoring system seems get guaranteed. So so cumulative demands such as mathematics ensuring that students have retained their knowledge is critical. So and here there is another interesting EDM problem, that is the diamond on the right, which is trashing. So when it is a student likely to fail a master skill in a timely manner and exhibit negative behavior such as gaming or any other skill like that, we have made progress on this progress on this problem as well as a double phenomena. So that is called trashing. Like if a student is likely to master a skill via problem solving, so it is essential to do something else such as peer tutoring or having a teacher intervene or providing instruction with the intelligent tutoring system. So and EDM provide actionable information for the intelligent tutoring system to make use of the decision making. So if a student appears like a retained to skill, so it is probably not necessary to keep presenting items. Like so if a student is likely to not master skill, then it is probably not productive to keep presenting problems. And taking everything into consideration. So firstly, the first attempt was teasing apart from the user ID factor, that gave not good results, but the area was like enough to do further study. So and we also got other issue with the that we are interested in addressing, we are adding additional features to relate to forgetting. So there are like a little existing work in student modeling. So finally I would like to deploy that this model is to working ITS in this field. On one hand, this can help the to verify the model. On the other hand, it could be used to improve the intelligent tutoring system to help the achieving long-term mastery learnings. And this paper present on the intelligent tutoring master learning diagram, which brings us useful problems in data mining that needs more work. So in this paper, they concentrated on estimating student knowledge retention and discovered some useful features for this task. Also, they were capable of to conclude student long-term performance is predictable, like even when a student ability to remember a skill comes into play. All right. Thank you. Any questions?